All right, so hopefully you're giving this a go, or at least try to set it up. There is supposed to be parentheses in front of this. That was a typo. I apologize. So C is the midpoint of line AB. So if I draw line AB, C is the midpoint, and then D is the midpoint of CB. So between C and B is D, which means this is congruent to this, and then ultimately A to C is the same as C to B as far as their length should be the same, because that's the definition of midpoint, right? And then A is located at negative 3, 5. And B is located at 4, negative 6. What are the coordinates of D? So I'm looking for the coordinate for D. With the A and B given, you can't just solve for D, like go directly to D. You could graph this on like actual graphing paper as well and not have to do the mathy form. You could count it out to find C and then count it out midway through to find B. But algebraically, remember, midpoint is x plus x divided by 2, comma, y plus y divided by 2. That would be your new coordinate. Or as I like to do, so stack them, add them. So stack them, add them, and then we're going to divide by 2. So negative 3 plus 4 is going to be positive 1. 5 plus a negative 6 is going to be, yep, Logan, that's good. It's going to be negative 1. We're going to divide them by 2. And so I have 1/2 and negative 1/2 for coordinate C. Is everybody okay with that, what I did to find C? So take the 2 points that are given, add your x's, add your y's, divide by 2. Now don't jump. If it was multiple choice, that answer choice is going to be there, but that is not what it's asking for. So again, we need D. So I'm going to do the same thing with C and B, and then I'll end up with the midpoint D. So I'm going to take 4 and negative 6, that's x and y, and then 1/2, which is positive, and negative 1/2, which is negative. Add them. So I'm going to do 4.5, and then I'm going to do a negative 6.5. We're going to divide those by 2 because we stacked them, add them, divide by 2. So 4.5. So if you have $4.50 and we split it, it's going to be $2.25. So 2.25. And then if I have $6.50, it's definitely going to be $3.25 if I split it and it's a negative. So then the midpoint of CB, otherwise known as coordinate D, is going to be 2.25, negative 3.25. I think my biggest piece of advice is either actually graph it on a piece of paper or definitely take a minute to sketch a diagram of that problem. This was one of the originally released EOC math problems from the state back in 2018. They've released one more version since then, and it's not exactly identical to this. It's like the one we did at the end of class yesterday. That midpoint was the one from that EOC packet. But as long as you are willing to draw it out and you remember midpoint, then you should be good. Any major questions? All right, number 10. So exponential laws. Which expression is equivalent to, so x minus 2 over y to the 5th power? Not a lot has to change in this guy. Your big red flag should be that negative exponent, because we can't have negative exponents. We can't leave them alone. And then when you have a negative exponent, that just pushes it into its other place. So if it's in the numerator, it drops down to the denominator, becomes positive. If it's in the denominator, it pushes up to the numerator and becomes positive. So in this case, he's going to drop down and become positive. So y to the 5th, x squared. A lot of students, and I don't remember, I think it was actually in Math 3 yesterday, were confused. You have to put that 1 on the top. It cannot become y to the 5th power x squared. because at that point the denominator becomes a numerator. And 1/4 is a far cry from $4 versus having a quarter in your pocket is two totally different conversations. So it is hugely important that what is in the denominator stays in the denominator. So in that case, that 1 on the top holds the lid down on whatever's down in the basement down here. And then the order of this is, some people, make a big stink about it. The highest exponent first. But ultimately, our answer should be A. D would probably be your trip you up answer, the misconception they're most prepared for you to make, because again, you lose the 1 on the top, and because you just don't write it all down, and it becomes a numerator instead of staying in the denominator. Now, number 11, two functions are shown below. Which of the following points to the graph of the functions intersect? So which of these points in the bottom cross each other? So you can do this algebraically because that means they're going to equal each other, right? So substitution, when we were doing, this is still systems, we just now have a quadratic. So we can set them equal to each other and then solve for x, or you could graph it and go look. If you do solve it for x, because this is a quadratic, that x squared, we want everything on this side. So I'm going to minus 11x, and on this side I mean relative to your equal marks. And then I'm going to subtract 13 from my constant over here. So I end up with 3x squared plus 3x minus 18 equals 0. And then from there, you would solve it for your x values. There is a GCF, 3, 3, and then 18 is divisible by 3 as well. So we could factor out a 3 and end up with x squared, which is great because now a equals 1. And that's going to be 1x, and that's going to be minus 6 equals 0. So that's factored out the GCF. A is now 1, so I can use my diamond or star method where I have a negative 6 on top, positive 1 on bottom. What two numbers could I multiply together to get a negative 6? So we're multiplying to get a negative 6. The sum, add or subtract, depending positive, negative, to get 1. My factors of 6 are going to be 1 and 6 and 2 and 3. 1 and 6 will never give you 1, whether we add them together or subtract them. So it's definitely going to be a 3 and a 2. Our B value is positive, so the largest of those two numbers needs to stay positive. 1 needs to be negative because it's actually 3 minus 2 would give me that positive 1, and 3 times the negative 2 gives me that negative 6. So GCF of 3, then I have x plus 3 and x minus 2. So now this is our factored form, so you've now factored it completely. But in this case, we're looking for when it touches each other. So we want to know what x is equal when these two graphs are equal to each other. So then we would solve the two factors. So x plus 3 equals 0 and x minus 2 equals 0. So x is going to be a 2 and x could be a negative 3. Hopefully if you get that far, A and D are off the table and your B and C are your two options to check. At that rate, you just plug in the x value and solve for the output. And you want to plug in both because one of them might work. Both could theoretically work. This is a quadratic at the top, which is a U-shaped graph. It's a smiley face or a sad face, depending if it's positive or negative. So if I have a negative 3, I'll be honest, I'm going to use the linear just because it's a little easier. Can do some mental math maybe. So 11 times a negative 3 gives me a negative 33 plus 13 will give me a negative 20. So up here, negative 3, negative 20. That one's looking good. If I take my 2, so 11 times 2 plus 13 is 22 plus 13, and that is 35, which looks good. So from that solving, those both are good answers for this one. Let's see if I can make this work. I did put it in Desmos, and hopefully you can see it. So again, type in one function, type in the other function. It's just like when we did our linear equation systems, but we're looking for the gray dots. Click it, negative 320, they definitely touch. Scan up here, click again, 2 and 35. So they both are good answers. This is just not a good A, B, C, or D question in the formatting. It touches in both of those two places. The linear function being the blue one, and your quadratic parabola being the red one. So either way, if it's calculator active, obviously graph it. If it's not, then the factoring way we just did would be your best shot. I see tricky format. It shouldn't have been an A, B, C, D. Or the question should be like circle all points, all the ones that could work. Bad formatting of question. Because it touches in both, quite obviously. Like we can't even pretend like one doesn't work. If it said which of the following, maybe to narrow it down to one, maybe they say the positive X value. So then you would choose 235 would be maybe how they could make that less vague. But ultimately, B and C are correct to the way they worded the question. So both of these are good. It does touch in both of those places. So again, when it says when are they equal, that means when do they touch graphically, or algebraically you set them equal and solve. Number 12. Okay, this bugger is on every EOC I've ever seen for Math 1. But it might be a rectangle versus a triangle versus a square. The shapes could change, but the process is still the same. Perimeter of a triangle. Perimeter means add up all three sides, right? So perimeter is side 1 plus side 2 plus side 3 equals perimeter for a triangle, right? All three sides, add them together. If I have one of them as x plus 1, we can call that side 1, call this side 2, we'll call this side 3. So side 1 is x plus 1. We'll add that to side 2, 3x minus 1. I don't know what goes right here because we don't have anything for side 3, but we know that it's going to equal 8x minus 6 when we're finished. So the simplest way to set it up would be probably that way if you're doing it algebraically. So we want to combine like terms on this side of the equal marks, which is going to be 4x plus 0, right? Because positive 1, negative 1 is 0, x and 3x, because we're not doing inverses because we're staying on the same side. And then we're going to go plus smiley face because we don't know what this is. Equals 8x minus 6, right? So if we get this 4x plus 0 added to this other, in this case, it's definitely going to be a binomial. The inverse of adding it to something is subtracting it from where you were, right? So if I took this away from this, then I end up here. Because, and let's see if I can make this more simple. So 2 plus 4 equals 6. If I took away the 4, and we didn't know what it was, 2 plus what equals 6? If you take away the 2 from both sides, then we know it's supposed to be a 4. And probably 2 and 6, you can do that math in your head. But the way you did the math in your head was take 2 away from 6 anyway. So we're doing the same thing now that it has variables in it. The 0 we can probably ignore for the most part. So we just have a 4x that we're going to take away from 8x minus 6. And we're going to end up with 4x minus 6. So that means side 3 should be equal to 4x minus 6. The other way you could do this, I'm trying to think of ways around it in case that did not make sense. At this point, you could take all your sides and your answer choices and add them together. So x plus 1, 3 minus, x minus 1 plus the first one, and see if you get out 8x minus 6. Since we know it's the second one, we're going to check it because this is definitely our right answer. So x plus 1 plus 3x minus 1 plus 4x minus 6. And remember, the parentheses are irrelevant when you're adding anyway because you're going straight through. So I have x plus 3x is 4x plus 4 more x is 8x. I have a positive 1 and a negative 1, and that's again going back to that like combining like terms. So my x values, x values, x values, because this is just an expression. It's not that it's crossing over the equal mark, so we're just cleaning up. Positive 1, negative 1, and negative 6 is going to give me minus 6. So that means we did get the correct perimeter as they wanted us to. Otherwise, you could probably type it in Desmos. And I would just type it in Desmos just like this. This one, this one, this one. See what it should give you this when it's out. And then do the first two plus the next one, the first two plus the last one, and make sure if you don't want to do it algebraically. Like if that did not make sense algebraically. It should, I'd be guessing actually to say that. It may be calculator active or not. Those numbers were not complicated, so I would say it's a fair game that it could be either place. But if calculator active, the way to do it in Desmos would be work through your answer choices, basically. Yeah, that's it. So number 13, G of 30. So you guys tell me, this is back to our function notation, which I feel like was a long time ago relative to when we first were exposed to it. G of 30, is that 30 a y value or an x value? Yeah, exactly. Because it's g of x, right? I pulled this x out and I put a 30 in its place. And remember, g of x as a whole, the whole thing is what we like to call y. So that's the output, the whole thing. The input is the guy that's put in there. So input, remember that is our x value. It is independent. It is literally inside the parentheses. The output, so the whole answer is your y, so that's your output. And it is dependent on what you plug in the place of x. So in this case, it's g of 30. So we're going 19.60 plus 1.74. And they're asking, this question is saying, what is y when x equals 30? So that g of x, like this, is saying, what is y when x is equal to 30? Like conversationally. So we're going to take that 30 and we're going to plug it in here. And we're going to solve. So 19.6 plus 1.74 times 30. What did you guys get? Yeah, good job. So 71.8. And then just to be slightly repetitive. So then this could be written, g of 30 is equal to 71.8. And that is saying that when x is 30, y is 71.8. So it can be written as a coordinate. Also, to write it backwards, g of x is equal to 71.8. So y is 71.8. It's probably rarely going to be written that way because if it is written that way, x is still in your equation because it's the original. This is probably the two ways you would see this answer because this one is actually just as good as the g is 30. This is right, is the question is saying what is x when y is equal to 71.8. Just like this was saying, what is y when x is 30? So this is still slightly a question form instead of a definitive answer like these two. All right, Ralph compared the slope of a function 3x minus 3y equals 9 to that of a function that goes through the points 5, 8, and negative 2, 15. What is the slope of the function with the bigger slope? So we need to figure out the slope for both of them, right? So 3x minus 3y equals 9. As is, do I know the slope of that line? This is in standard form, is what they call this. Standard form. Standard form is not very helpful to find slope. So we want to convert to slope-intercept form. Slope-intercept form is that y equals mx plus b. So ideally, we're going to solve for y. Yep, getting way closer. Good job. I see it in the box. So we want this guy. But even stopping right there, you're going to have a misconception, right? So that 3x is going to come over. It's going to become negative. So it's negative 3y equals to negative 3x plus 9. I still don't know my slope because y is not by itself yet. I'm going to divide by -3 all the way through. And that's going to give me y equals a -3 divided by -3 is a +1. 9 divided by -3 is going to give me a -3. Sorry, I ran all into my words. So looking at this slope-intercept form, what is the slope? What is the m value in y equals mx plus b in this case? You guys tell me. Yeah, exactly. So m equals 1 for our function that's an equation. Now, with my two coordinates, remember it's y minus y over x minus x. Or stack them, subtract them, which is going to have a minus minus. So 5 minus minus 2 is going to be 7. 8 minus 15 is going to be a -7, right? Is everybody okay with that so far? And does y go on top or x go on top for slope? For rise over run, is rise y or is rise x? Yes. So remember, these are the coordinates. So -7 over 7. In this case, not a huge deal because that's going to reduce to a -1. So which one has a bigger slope? A little tricky answer, relatively, I guess, because the rate of change would be constant. They're just in different directions. One's not steeper than the other. One's just positive and one is negative. So ultimately, the bigger number would be +1. You'd rather have $1 than owe somebody $1. So our equation function has the larger number slope. If it's discussing steepness, so how fast is it increasing or decreasing, they would be the same. One is just positive and one is negative. So one is increasing, one is decreasing. But their steepness would be the same, just opposite directions. All right. We've done one of these already before. So I'm going to pause and let you try this guy. A football team purchases Spirit shirts to sell at their games. Those of you who've not chimed in or typed in, I would love to see you type in, guys. A football team purchases Spirit shirts to sell at their games. Each box contains 50 shirts. Each box costs $250. How much does the team have to sell each shirt for to make a $150 profit on each box? How much? So we're looking for the cost that we're going to charge to come out with $150 profit. Like I said, I'm going to give you a minute to see if you can get that one. Come up with a good answer. All right, we got an answer. Anybody else coming up with a good answer? I can't beg you enough to try these, guys. Thank you, boys. All right, so math teacher equation was, all right, we got lots of answers. Let's see what we got. So ideally, we have 50 shirts times some amount plus minus 250, right? Minus 250 because we got to spend it to buy it is going to equal, we want it to be equal to 150. That would be your probably easiest equation, maybe. Or in your mind, if you know they cost 250 and you got to make 150, you may have even set it up as 50x equals 400, because that's how much money you have to make. If you've ever sold things, maybe you just thought like, I have to make $400 to make $150 profit after I spend the $250 to buy the box. Which if you did it algebraically, that add that 250 to both sides is how we get here anyway. And then from here, we're going to divide both sides by 50. So 400 divided by 50, x equals 8. So $8. So we have to charge $8 per shirt to get a $150 profit, knowing that we have 50 shirts and each box costs $250. Oh, no worries. No worries, no worries. It happens. Okay. Jeremy compared the y-intercepts of the graph. Hopefully those of you have been showing up a lot. Y-intercept, that's when x is 0. This is also known as the starting point. It's on the y-axis. Again, knowing that x is 0. Of the graph of the function 3x minus 5. So from 3x minus 5, what is our starting point or y-intercept? What do you know is the y-intercept or starting point from 3x minus 5? Looking at that equation, somebody tell me what the y-intercept is. So again, you're thinking y equals mx plus b. M is our slope. X and y are x and y. So it's our b value. Yep, you got it. So the y-intercept for the first one is going to be negative 5, right? So negative 5 for our equation. Looking at this guy, right now, we don't know what the y-intercept is. So I would take this to Desmos, probably would be the easiest thing. Because it's quadratic, it's definitely not going to be linear, and you'll get more comfortable with this, like I said, in the next couple weeks. That turn point, this portion of the graph and this portion of the table are going to match because you can see the negative 12 on either side. The next one would be 0. So if I added, it looks like it's going at a rate of 2. So if I plugged in 2 into this function, ideally it's going to be a 0. But I'm going to switch over here to Desmos, if I get my mouse to come back alive and get me over there again. And we're going to put in the table real quick. So Desmos, we get rid of these two. Also, just to make sure we know how to put in our tables. So I'm going to add an item, add a table, and I am going to put in the negative 6, negative 4, whoops, that's 0, I'm sorry, negative 6, 0, negative 4, negative 12, negative 2 was a negative 16 as my output, and then 0, negative 12. Now, we don't see it because my graph is way up here looking at these high numbers, so I'm going to slide down. I've got 1 dot, 2, 3, 4. And hopefully, again, after we do this some more, you see that this is going to make a U. So this is our parabola. So we're going to write this as a quadratic function. Or, ultimately, I guess, really, you can see, oh, I'm making you do a lot of work. The table tells you that x is 0. It touches the y-axis, at negative 12. Just because we're here, if you wanted this quadratic function, again, just to practice, so y down 1, we're going to use the, I don't have it on my keyboard. You might have it on yours, so I'm going to go here. Maybe it'll let me. There we go. And I'm going to use, I need that to go away, ABC. Did I get out of my way? We got our squiggle. This is AX. And we need to do sub 1 up squared. So you see how it's starting to make a quadratic? You can see it negative here, right here, ax squared. Y equals, I'm not sure what's negative. It should not be negative right now. But, oh, it's using our parabola. I'm sorry, it's using the graph that we had there. And then plus bx sub 1, whoops, sub 1 plus c. So it just wrote the parabola here that we would need to get the line of best fit for that data in quadratic form. So we would plug in a 1 in front of x squared, a 4 in the front of x, and a negative 12 at the back. So that means our function for that graph, not necessary for answering this question, but is going to be necessary across the board. Our b value is 4x and then minus 12. So coming back again, the question is asking where does it touch the y-axis, or what is your starting point in comparison? So this is the function we just got there. Again, y-intercept is when x is 0. It is also always the constant in a quadratic equation. So it's going to be the number that does not have a variable if you were given an equation that was quadratic. So what is the difference? So in the y-intercept of g of x, so the y-intercept of g of x, like I said, also you could have found it right here in the table. Sorry, I overlooked it. Is negative 12. So when the y-intercept of g of x is subtracted from, so it's going to be a minus, the y-intercept of f of x, which is negative 5. So it's taken away from, so that's minus minus, which we'll turn that into a plus. So it's negative 5 plus 12. So the difference between those two is what? You guys tell me. I don't want to necessarily call people out by name, but a lot of you, I need you to start participating, guys. Yes. Thank you. So it's going to be 7. So negative 5 plus 12. So if I owe you $5 and I paid you 12, then that means you just made $7 off of me, right? So it's a positive 7. I gave you more than what I owed you. All right. Number 17. All right, rectangle, area, we're graphing stuff. So again, like we talked about yesterday, remember this is x and y. Every time you graph a point, you're going left, right first, then up. So I'm going to go over to positive 1, up to positive 2. Over to positive 5, and that's going to be 0. Positive 2, negative 6. And then negative 2, negative 4. And we want to connect those lines. And if you don't have a ruler, if you want to, you can use the side of a piece of paper when you're graphing it, because again, you are going to have a plethora, like so much paper. Please use the paper, write things down, take the time, because I'm telling you, every question you can get in the bag that you have the skill to do, they are going to put enough questions on there just to beat you up mentally that you're not necessarily going to have covered in our class. Oh, I'm sorry, Logan. It's because I just wrote it straight across to the right, that last problem. I apologize. But yeah, 7 was correct. You killed it. So you got it. Now we have area of a rectangle. So area of a rectangle is length times width, right? So I need to know the length of 2 of these sides. Not opposite sides, but corresponding sides, right? So length maybe, and then width. By doing the easiest way, in my humble opinion, you can use distance formula if you want, but they're not going to give you the distance formula. So you have to, should be around 60 to 65, Joseph. You have to use something that you remember. I like Pythagorean theorem, which means I'm going to turn this into a right triangle. This is a rise of 2, a run of 4. So I have 2 and 4, and then I'm going to find out what this is by using a squared plus b squared equals c squared. C is always going to be your hypotenuse. Always, always, always. A and b can flip around. So then 4 squared plus 2 squared equals c squared. 4 squared, guys, I need you to focus on this, and we'll talk about all that in a little bit. Absolutely, I will answer your questions, but right now is not it. You have enough time. You have to get this math done, and some of you are still not answering me, which makes me very nervous. I need to know what I need to do to make you better for it. It is at least 3 weeks away. I promise you will know. As soon as all the information I have for EOC, I will put it out when I have it. I don't have it. It's 3 different schools. And if you will read public service announcements daily, that will be where I will put everything. And then when I get fine-tooth details, it will go out in announcements and in an email. So what is 4 squared? Hayden, what's 4 squared? Yes, sir. Thank you. Or ma'am, I'm sorry. Either way. Courtney, what's 2 squared? Timmy, what's 2 squared? Thank you, Courtney. 4, excellent. So from that point, 16 plus 4 is going to be 20 equals C squared. For an extra point on your today's assignment, for whoever tells me first, I'll give you an extra point in the grade book, and I'll probably just go throw in an assignment that's already in there. What is the inverse of squaring something? Yes, sir. Thank you, Logan. You got it. 1 point on your grade, on a grade in the grade book. So the inverse of squaring something is square root. So we're going to take, because that is C times C equals 20. So we're going to take the square root of both sides. In this case, the square root of 20 is ugly. We're just going to leave that alone because it's a decimal, and that's really all we need at the moment, because we'll undo it when we do Pythagorean theorem, which is a squared plus b squared equals c squared again. Or I'm sorry, when we start multiplying things together. So we'll leave it square root of 20 for accuracy. We need our length now. So we're going to look at turning this into another right triangle using your vertical and horizontal lines. So just straight across the already drawn lines until it meets the straight down of the other line. So again, this is going to be A and B. Hypotenuse is always C. Hypotenuse is always across from the right angle. So our A is 3. Our B is 6. So we're going to do it again. 3 squared plus 6 squared equals C squared. So somebody tell me what 3 squared is. Timmy, how about you? What's 3 squared? Yep, 3 squared is 9. Good job. What's 6 squared? Yes, good, good, good. So then that's going to equal C squared. So 36 plus 9 is going to give me what? So 36 plus 9. Yep. 45 equals C squared. The inverse of squaring something, again, somebody type it in there. What's the inverse of squaring something? Yeah, square root, square root. So we're going to square root this side, square root this side. Again, the square root of 45 is going to be some nasty number. It's not a whole number. So I'm just going to leave it the square root of 45 is equal to C. So this is our length. This is our width. So area for a rectangle is length times width. So we're going to take the square root of 45 and times it by the square root of 20 and see what we get. You guys try it in your calculator while I'm putting it in mine and make sure we get the same answer. Yeah, beautiful. Just so you can see, if you wanted to use the decimals, 6.71, I would go at least that far, and then 4.47, so 6.71 times 4.47 is close, but it's just not as accurate. So if you leave it in the square root form, you're going to have a calculator, you're going to have Desmos for this guy. I mean, it's not a nice, neat number. If it came out to be, what's the square root of 4? Hopefully you know that's 2. That could be calculator inactive. What's the square root of 9? hopefully you know that's 3. But as long as they're going to leave you with like funky numbers like this, you're going to have calculator active. So I would leave it in the most accurate form and not chance it to improper rounding. In this case, obviously, it's really close to 30, so you're fine. But sometimes it may not be as obvious. So your answer is going to be 30 units for the area of a rectangle. So area of a rectangle is length times width. Just a comment to throw out there, maybe worth making note of. Area of a triangle is another one that I've seen kind of pop up in some places when I'm looking for a review. And that's 1/2 base times height. Or depending on your teacher in middle school, it might have been base times height over 2. So that's the area of a triangle. Rectangle, triangle, and square, I would make sure are somewhere vaguely close. Don't super stress about it, but they usually keep it to those basic shapes. Rectangle, square, triangle, maybe a circle for area, which is pi r squared. That's area. And then perimeter for a circle, or circumference, which is perimeter, is 2 pi r, or again, depending on your teacher, it might be pi diameter. So that's your circumference, if you want to make note of that somewhere. Not a huge deal, but just because they are assuming that you have those in your brain bank already from middle school. And they are, like I said, they'll throw some questions out there that you'll feel like we didn't cover in class because they're using knowledge that they assume you should be bringing to the table. Alrighty, number 18. Margaret is twice Susan's age minus 21. Margaret is twice Susan's age minus 21. Susan, on the other hand, is 3 times Margaret's age minus, I wonder if I made a typo. I bet it's minus 17 and not 177. How old is Margaret? We are definitely going to put minus 17, because if not, I think she's going to be real old. And we're going to rock and roll and hope it comes out as a good number. All right, so Margaret is twice Susan, so 2s minus 21. You okay with that one? Oh, this looks like an S, not a 5. Susan is equal to 3 times Margaret's age minus 17. Now, in my opinion, substitution is going to be the easiest way to go about this. But if you want to do elimination or to graph it, you can identify, like, say Margaret is X, so Margaret is X. Susan is Y. So Susan, and we'll go put it in Desmos in just a minute and see where they cross. But algebraically, so substitution, in my opinion, would be a little bit easier without doing a lot of work. So Margaret is equal to 2 times. This whole thing is Susan's age. So it would be 2 times 3m minus 17 minus 21. And if we come out with a negative, it's because I just made I just switched that number up. But I don't feel like 177 is correct. So 2 times 3 is going to be that 6m. 2 times the negative 17. What's 2 times the negative 17? Anybody want to tell me what's 2 times a negative 17? Good job. Thank you. Negative 34. And then minus 21. Now you're going to clean up on one side of the parentheses. So I have m equals 6m. These guys are like terms. So if I put those together, I end up with a negative 55, right? I need to get my m's away from that 55 because there's 2 m's. I'm going to move this guy this way because it has to be away from the constant. So I'm going to subtract 6m because he's positive. So negative 5m equals a negative 55. How am I going to get m by itself? How am I going to get that negative 5 off of m? Yes. Why do I divide? Can you tell me why I have to divide? Inverse of. What is the inverse of? Yes, you're right. Yeah. Negative 5. Negative 5. So Margaret is how old? 11. Yep. So Margaret is 11. And that's the question that they ask. So ultimately, we can be confident and be done. But because we're here and we have Desmos working, I'm going to go over here to Desmos, and we're going to check it out and see if we did our math right. So the first equation in this case, and I'm going to go at it like a student would and not do anything crazy, x equals 2y minus 21. So all you had to be able to do is set up that equation, and then y equals 3x minus 17. Where did they cross each other? 11, 16. And again, that would be, as long as you remember that x is Margaret and y is Susan, then here's your x value. And I don't know, actually, now that we're doing this and I'm here, let's try M and S. Oh, it'll work. Cool. So you can even do it with your, no, it doesn't. Okay, that's what I thought. So you have to use X and Y. So make sure you identify which one is X and which one is Y. I would make a small little table on the side of your paper, even though you think you're going to remember. Just trust me, it gets real weird in that classroom with all those test questions and all that stuff going on. So make a little note to yourself like Margaret is X if you choose to do it that way, and Susan is Y if you don't hang on to your variables as kind of the words so they don't get mixed up. Consecutive integers. Woohoo! All right, the largest of three consecutive positive. Consecutive positive. So consecutive is x, x plus 1, x plus 2. If it had said even or odd, it'd be x. So even or odd is x, x plus 2, x plus 4, and so on. This is not what we're discussing, so we're not using this. We're using these guys. Because it just says three consecutive positive integers. And it says if the sum of the smaller two is 11. So I'm going to add these two together. So x plus 1 equals 11. I'm going to pause for a minute and see which one of you can tell me what the value of x is. I'm going to let you solve that bad boy. So x, yep. 2x plus 1 equals 11. Minus 1 is going to be 2x equals 10. Divide and x equals 5. And the way you guys did it, 5 plus 1 equals 11, that works as well. It's ultimately the same thing. It's just how your brain got there. So x is 5. And it says, what is the largest of the three? So if x equals 5, x plus 1 equals 6. X plus 2 equals 7. So the answer to this question is what number? Yes, 7. And I've said it 100 times. If it's a multiple choice question, guarantee they will give you 5 as an option because you get excited. You did the hard part and you jumped. So be careful to go back. What is the largest of the three consecutive? This is just the first consecutive, and since they are positive, it's going to be the smallest because they are positive. If it is negative, be careful as well, because if that was a negative 5 and we were going consecutive, it would probably be a negative 4, negative 3, and then the largest would be the negative 3 still, so it would still be positive, sorry. Yep, still be the smallest. Just make sure we're reading. Really close. Read the question, do the math, read the question, then answer the math. Cannot reiterate enough how much slowing down helps. All right, number 20. 6 organisms are present in a sample now. If these organisms double every 30 minutes, how many will be present after 90 minutes, assuming none of them die? Most of you, I think, are going to do this through logic. So I'm going to give you a minute because I think you can answer it without me showing you the equation style. Or if you do it equation style, that's perfect too. But you guys try it. Try to come up with an answer for number 20, please. Keep working. Close, but no dice. The biggest thing would be to maybe identify the 30 minutes, and we're tracking it for 90 minutes. So think about how many times did that 30 minutes occur within that 90 minutes. Not it yet. Keep going. You got it. All right, I got a couple good answers in the box. Let's see what we're doing. So again, you can do this a lot of different ways. The mathematical, like exponential growth, would be start with your 6. It's going to double that 30 minutes. So it'd be 90 divided by 30, because that means it happened 3 times, right? So 6 doubling 3 times, because each 30 minutes, 90 divided by 30 would be 3. Logic, 6 is going to double to 12. So that's your first 30 minutes, right? Then that 12, is going to, double to 12. 12 doubled is going to be, oh, Hayden, I'm sorry. You had it. Is 24. I was doing mental math and did not do good. That's my second 30 minutes. And then for my, no, you didn't. Somebody did. Oh, y'all are so close. Good job, Courtney. And then it doubles one more time, is 48. And that 30 minutes, 30 minutes, 30 minutes, there's our 90 minutes. So that 6 organisms became 48. Do we see what we did with that now? I would say probably if you try to do it in your head, that was a terrible decision. I would write it down. Either use the equation or do 6, 12, 24, 48, just like I did. Mental math is fun and it's awesome. But again, on an EOC, that's not the day to do that. Trust me. Not that you can't. It's just there's a lot going on and you're bouncing around in a lot of places. You're going to get tired. You're going to get cold. You're going to get warm. You're going to get exhausted. Have no desire to do anymore. But if you're writing it down, you're not going to blink or brain hiccup, like I like to say, and miss something that's pretty simple. Because I think most of you, hopefully, if you just saw that, were like, oh, yeah, easily, for sure. Because they're right there in it. I mean, it's the math. You're taking the 90, you subtracted 30, you get 60. The 90 is already there. We like numbers that are there. We think things should be straightforward. I will say, and I say this semi-cautiously, EOC level Math 1 questions are very rarely just the number in the word problem, if that makes sense. It's not 8th grade level math. They may have more been testing, are you reading appropriately, right? Like, are you understanding what you're reading in that case? This time, like Math 1, because the math is not that much different than what you've done before, they want to make sure you can read it and apply it. So it's definitely going to be very little reading comprehension straightforward. It's going to be reading comprehension to then get pushed into the computation part, the mathy math part. And you sometimes can get by with just doing a logic table like we've done with the sheets in the pillowcases, or like in this one. It's not totally out of the picture, but it's definitely not something you want to try to do in your head, ideally. All right, at 3 minutes, I'm going to go ahead and hit the next one. If EY over N plus K equals T, what is Y in terms of E, N, K, and T? So we're going to put it in Y equals form. This one is a hot mess. If you were dazed and confused a moment ago and you're not writing anything down, write this down. It is not terrible. It is lengthy. So ideally, we are trying to get this guy. We're shooting for that Y that's up in the top right now. What is on the outside of the box? That should be the first thing that I should move. What's outside of everything attached to my Y? What letter? And then how is it attached? Yes. And it's attached by addition. It's positive. So how am I going to move it? What operation will I use to move it? Yes. So I'm going to subtract K. One step at a time. So I have E, Y over N now equals T minus K. I want Y by itself, which is on top of this N. So I'm going to take care of anything in the basement first. So that N, that's EY divided by N. How can I get the N out of the denominator, or quote unquote out of the basement, as I like to say? Do we remember? Yes, good. Multiplication is the inverse of division. Oh, I just made an M and I meant N. N. Turn that to an N. These N's cancel out. So now I have E, Y equals, and I'm just going to leave it like this for right now until I want to go look at my answer choices and see what format they put them in. What's attached to Y now? What do we need to move? What letter is still there? We need Y by itself all day. Yes. How is it attached? What operation is E attached to Y with? It's like my favorite question. I don't understand it. Always, yes, good. It's E times Y. I love it. I don't know where we skipped all this way back in the day, but it became EY, and it's attached by multiplication. So the inverse of multiplication is what? Yes, we're going to divide by E. And I know you're rolling your eyes on the inside and being like, why is this happening to me? Why can't we just divide by E? Why is she asking me these questions? Trust me, in the future, you'll be happier if you can answer all of those things. What's up, Randall? What's up, Annabelle? Sorry, we're wrapping up a math one. Get together. All right, so T minus Kn all over E. If I look at my answer choices up there, the first one, they didn't distribute the N all the way through, and it's a plus. The second one, again, they did not distribute the N all the way through because it would be N times the whole thing. So that's no good. The minus is looking better. N, there's that added K, but remember, we started with an added K, so it's the opposite. So our answer is going to be the fourth one. So just like we had it in the way we wrote it.